Okay, we want to find the first four terms of Maclaurin series for sine of 2x by three different ways. Okay, the normal way by finding all those coefficients by taking a bunch of derivatives and then using what we know. We already have a Maclaurin series for sine x, so we're just going to fill in x with 2x, see what happens. And then this one's tricky. We're going to say, all right, I'm going to start with the sine x series and then multiply it by 2 cosine x, because in trig we learned that the sine of 2x is 2 sine x cosine x. Okay, that was a tough one. But the first two, let's see if we can figure out. Question A is a pretty common question, so here's how it goes. I'm saving some time by just giving you all these derivatives. So you start with the function, right, and plug in 0, Maclaurin series. Then do a bunch of derivatives, enough so you can get the first four terms. Why do I have to go 7 deep? Because of these zeros, right? Which should make sense to us because that looks a lot like similar to the sine function and the cosine function. Okay, so here's what you get when you go to your formula for Maclaurin series, right? You're going to plug in all of these coefficients that you got and go with your powers starting at 1, 2, 3, 0, 1, 2, 3, and so on, and you'll get just odd terms. Okay, so hopefully that made sense without me actually doing it step by step. There is your series for sine 2x. And here's another way to do it. Here's an easier way to do it, right? And we do this a lot in here. We say, well, I already know what sine x is. It's this thing. So what I can do is find a series representation of sine of 2x by replacing x with 2x, right? And that's the only change over here. And then, because the question's asking, there's your answer, right? But because the question is asking for the first four terms, then we can go ahead and write those out. Right, and that's okay. This answer is okay, or you can multiply those out so you can actually see that this answer is the same as this answer, right? They should all be the same answers. First four terms, right? Yeah, first four terms. Okay, so now hopefully that made sense. This is the kind of regular way. Start at scratch, find your coefficients by doing a bunch of derivatives. That's most of the work. The rest of the x values comes from the formula. Shortcut method. If you know what sine is, we can get sine of whatever by just kind of plugging it into the sine function for first four terms. And now for the fun one. Okay, I'm going to do this one. I like this one. This one was pretty tough. I think I'm just going to, when I grade, I'm in the middle of grading. I think I'm just going to give you a pass on this one because it was pretty challenging. So let me show you how it goes. It goes like this. Okay, so we know what the sine function is, right? We know it's this guy. So we have sine x is equal to, and if I write that out, which I think I'm going to have to do, I mean, if you don't write this out, the solution for sine, then you're going to have you could write the cosine sum as well, but then it's gonna get a little messy. I think it'll be a little bit easier if I rewrite. Remember, we always have, and this is something that always comes up. We got that series representation for sine, and we also have this series representation of sine, right? They're the same thing. Which one are we going to use? Well, the one that works best for me, and I'm going to go ahead and do my factorials. Okay, that's your sine function as a power series. And then what I'm going to do is I need to look at sine. I want sine 2x, right? So sine 2x is 2 sine x cosine x. So it's 2 times sine x, 2 times this thing, times the cosine x, right? So we can go look up our cosine x function, which I don't expect you to know. Remember, I'm going to make this final. Let's see. If I wanted to say, oh, what's cosine? It could be on your index card, or you can go to your book, because it's going to be open book. And I would say cosine x, what's that? What's that? I go to this list is pretty useful, or you could just put it on your index card. Here's your list, right? And I referred to this earlier. And if I can cosine, right, there's the sign. That's what I'm using, right? We have, like I said, kind of two versions. The one there where it's written out, and then the one where it's condensed as a sum. And then we have cosine, and that's what I'm using here. So I got 1, and then it's all the even terms, okay, alternating. So back to that, 1 minus x squared over 2 factorial. 1 minus x squared over 2 factorial. Minus x squared over 2 factorial plus x to the 4th over, I'm going to go ahead and figure out what 4 factorial is. It's 4 times 3 times 2. And the reason why, I'll show you in a minute. I guess I could, 2 factorial is just 2. And then I'm going to go ahead and figure out what 6 factorial is. And I'll show you why. And dot, dot, dot. And let's see if that's enough. Okay. So that is sine 2x from our trig identity, 2 sine x cosine x, where 2 sine x cosine x. And now what do we have to do? We got to multiply these together. Okay, so that's equal to 2. So I got to multiply all of these by all of these, right? So I'm going to take my x and run it through. So I get an x. I get a minus x cubed over 6. And then I'm going to start thinking about, well, how am I going to get, what am I going to do with this? It's going to be a total mess. But if you think about it, you should have, if you should have multiple powers that agree. That is, you should have cubic terms. What kind of terms do we have? Well, that'd be an x to the first, x cubed, x to the fifth, x to the seventh. If I run the x cubed through, I'm going to get x cubed, x to the fifth, x to the seventh, and then an x to the ninth. But I'm going to stop at x to the seventh because I have an idea that's my last one. Okay, so I got an x cubed, and then I have another x cubed if I ran this one through. And then we got an x to the fifth. I got an x to the fifth here. So in other words, I should be getting odd powers, right? Which agrees. That's my answer. So what I'm going to try and do is group my odd powers. So I got an x to the, if I multiply this x by this one, it's x cubed over 2, not 6. But I will have an x cubed over 6 when I multiply this by the 1, minus x cubed over 6. Okay, so that's all the x cubed terms I'm going to get. Now what else am I going to get? I'm going to get x to the 5th over 24. How many x to the 5th terms do you get? Well, this will give me another one, this x cubed over 6 times x squared over 2. So that's going to give me a plus x to the 5th over 12. And then I should have one more x to the 5th term, I think. I got this x here, x cubed, this guy, that when I multiply x by this term, gives me an x to the 5th term. Okay, you see where we're going with this? And I only have to do one more, only one more, because I got 3 terms already. 1, 2, 3, and then I'll have a 4th term with my x to the 7th term. So if you do this, there's going to be 4 of these if I did it correctly. I should have a negative x to the 7th. Let's see, this guy. Negative x to the 7th over 7. That's a 720. And then I'll spare you from doing all of them. You can figure out what they are. Here's another one. This times this would be a negative x to the 7th over 5,040. But there should be 2 more in between. So I got a negative x to the 7th over 144. I got a negative x to the 7th over 240. And then I got a minus x to the 7th over 5,040. Okay, and I'm probably going to lean on a calculator to add these fractions together. 1/24 plus 1/12 plus another 1/24 should give me, for my x to the fifth term, 4/15. Okay, so now my answer is these guys. All right, well, we'll skip a step. It's a lot of arithmetic, but take my word for it that this is equal to 2x minus 4/3 x cubed plus 4/15 x to the fifth minus 8 3/15 x to the seventh, dot, dot, dot.